So now let me repeat what we learned last time. Okay, so last time we learned about simple machine. Okay, and I gave some examples related to simple machine. We also learned about the complex machine, and I told you something about complex machine, alright? And I gave you some examples related to complex machine. And we learned about the importance of simple machine, alright? Why do we use simple machine, alright? So these are the importance of simple machine. And we learned about load, we learned about effort, isn't it? So these things we learned in our previous class. Okay, now today we are going to learn further. Alright, so I would like to request you all to please I would like to request you all, please switch on your video. I need to see your face. All right, okay, keep your mic off, but you have to switch on your video. So Gaurav, do you listen me properly now? If you listen, then please raise your hand. Okay, okay, that's good, fine. So students, so last time we learned about the simple machine. Let me repeat for the last time again. We learned about simple machine. We learned about the importance of simple machine. We learned about complex machine. We learned about load, effort, and we even learned about the importance of simple machine. Okay, what are the importance of simple machine in our daily life? So today we are going to learn further. Okay, so number is increasing. All right, so we have now 20 participants. Okay, all right, Kelvin Sapkota, do you hear me properly? Is my sound clear?
Yes, sir.
Fine. Okay, Dilasa, do you hear me properly?
Yes, sir.
Fine, that's great. Karun Bhujel, do you hear me properly?
Yes, sir.
Okay, that's great. All right. Now, so sorry, now maybe your internet is slow, okay? And when you have very slow internet, then you sometimes sometimes audio is not clear, sometimes video is not clear, okay? So at the time we are having online class, so please ask your if anyone, okay, anyone from your home are using internet, so ask them not to use internet for a while, okay? All right? Because when a lot of people use the internet at the same time, then the data traffic might be high, and in that case the voice or video might not be clear. All right, anyway. Now let me share the screen. So we are now 21, and I have already told you, so please your video should be kept on. All right, I need to see your face. Okay, so I can see the face of only 1 2 3 4 5 6 7 8 9, altogether 90 students. I can see the faces of only 90 students. All right, but I can see the present number of students are 23. So that's it. I request all of you to switch on your video. All right, otherwise you may be out of the classroom. Okay, all right, now let's begin. Oh, so let me share the screen so you all will look on the 1 2 3 go. So okay, students, let me, so this is our slide. Okay, let me begin from, so okay, so machine. So as I told you earlier, there are two types of machine: complex machine, simple machine. And if we talk about complex machine, we learned last time. Okay, we learned about complex machine last time, and we also learned about simple machine last time, and we learned about the advantages. Advantages means importance. All right, the importance of simple machine are as follow. So you can see some points have been written in the screen, so you can see that. And then technical terms related to simple machine. So last time we learned about the technical terms related to simple machine, that is effort. So let me repeat, this one is important, so let me repeat once again. All right, so actually, so effort, so basically the force which we use or the force which we apply to do work, that is called effort. Let's say you want to lift a rock. Okay, you are lifting a rock by the help of hand, so your hand is used to apply force, so that force is called effort. So the amount of force applied on the machine to do work. Okay, the amount of force that is applied on the machine to do work, that is called effort. And usually effort that is measured in terms of Newton. You can see the Newton. Okay, effort is measured in Newton, that means the SI unit of effort is Newton. Now load. So if we talk about load, the force applied by the machine on the body to do work is called load. All right, let's say you are using a crowbar. Okay, let's say you are using a scissors to cut a piece of paper. All right, so the scissor is a machine. Okay, and then by the help of scissors you cut paper. That paper is a load. Okay, and let's say you are using crowbar to lift a load. Okay, in that case crowbar is a simple machine. Okay, and the load, I mean to say, let's say rock. Let's say you are using crowbar to lift a rock which is lying on the road. Okay, so in that case crowbar is a simple machine, and the rock which is lying on the road and you are trying to eliminate, or you are trying to remove it by the help of crowbar, that load, or we can say that rock is a load. So the force applied by the machine on the body to do work is called load. And same, it is also same like effort. Its SI unit is Newton. Okay, and that is noted by capital letter N. So that is all about load. And if we talk about, you can see the example there. A crowbar is used to lift a heavy load. Okay, so in that case, crowbar is taken as a simple machine. In this case, heavy object is load and the crowbar is a simple machine. So these things we learned in our previous class. Now, this is very much important one. Now we are going to learn about mechanical advantage, that is noted by MA. Okay, mechanical advantage. All right, so you can see the definition there. The ratio of load to the effort is called mechanical advantage. Okay, the ratio of load, ratio means division. All right, so when you divide load by the effort, when load is divided by the effort, in that case, that is known as mechanical advantage. So you might have heard this ratio in this word ratio in mathematics. Ratio means division. Okay, what is the ratio of 2 and 5? If someone says what is the ratio of 2 and 5, that means the ratio of 2 and 5 is 2 divided by 5, that is 2 is to 5. That is the ratio. Okay, so mechanical advantage is the ratio of load to the effort. That means when load is divided by the effort, then in that case we can calculate mechanical advantage. Okay, so you can see the formula there. Mechanical advantage MA equals to load divided by, you can see the sign division there. Mechanical advantage equals load should be divided by effort. Load is noted by L and the effort is noted by E. Okay, so load L upon E, that is called mechanical advantage. And let us talk about its SI unit. So since mechanical advantage is the simple ratio, okay, it is a ratio of two quantities. What happens when 2 kg is divided by 1 kg? When 2 kg that is divided by 1 kg cancel out, 2 upon 1, 2. That means there is no unit. Okay, so let's say, let us divide 20 centimeter by 5 centimeter. 20 centimeter upon 5 centimeter. Centimeter can be cancel out. 20 upon 5, 4. That is 4 upon 1. That is 4 is to 1. Hence the ratio is 4 is to 1. Since the mechanical advantage is the ratio of two simple quantities, same quantities, which is why it has no unit. Okay, let me go to the screen. So students, okay, so as I told you earlier, mechanical advantage is the ratio of two quantities. Okay, I give you example. Mechanical advantage is the ratio of two quantities. That means what are these two quantities? Load and effort. When load is divided by effort, then we can calculate mechanical advantage. Let us suppose load is 10 Newton. Let me give you one example. Let me share a screen. Okay, why mechanical advantage is a unitless quantity? In examination, this question might be asked. So let me share you one example. Okay, all right, let me give you one example. So the question might be asked in this way. Okay, anyway, so the question might be asked in this way. All right, so share. Okay, the question might be this one. This is quite important one, so please focus. Okay, why MA is a why MA does not have, this is very much important question. Why MA does not have any unit? So we know that, as I told you earlier, mechanical advantage equals to, what is the formula? So mechanical advantage equals to this one. So this is mechanical advantage. So as I told you earlier, mechanical advantage equals to load upon effort. So this is the formula to calculate mechanical advantage. All right. So let us suppose that load as 10 Newton. Let us suppose that load is 10 Newton, and again load is divided by effort. Let's say effort is 5 Newton. See that 10 Newton, this slash means division sign. Okay, let me write properly. Okay, equal should be at proper place. So let's say, okay, let us suppose that load is 10 Newton. Okay, 10 Newton, and then let us suppose that effort is 5 Newton. See that. So while we perform calculation, all right. So see there, this Newton can be cancelled out, isn't it? What when 10 Newton that is divided by 5 Newton cancel out. 10 upon 5, that is 2. Okay, so if you write here 2, if you write there, then we get 2. That means Newton cancel out. It has no unit. So we can say that hence Means MA is a simple ratio of two quantities. Oh, all right, so it does not have any unit. So this is the final answer. All right, so since in examination you can write only this one, you can write only this one, this you can mention. Since mechanical advantage, MA stands for mechanical advantage. Since a mechanical advantage is a simple ratio of two quantities, you can see there, that means load is one quantity and effort is other quantity, and the unit of load is Newton. Similarly, the unit of effort is also Newton. Newton cancel out, 10 upon 5, that is 2. Hence, mechanical advantage is a simple ratio of two quantities, so it does not have any unit. So this is how we can write mechanical advantage is a unitless quantity. So students, are you clear about that one? Johnson, are you clear? Why mechanical advantage is a unitless quantity? Johnson, please switch on your mic.
Yes, sir.
Did you understand that one?
Yes, sir.
Why mechanical advantage is a unitless quantity? Tell me. Or why
Mechanical
mechanical advantage does not have any unit?
mechanical advantage does not have any units because it is the ratio of two units.
It is the ratio of two same quantities, okay? Right? It is the ratio of two same quantities, which is why it has no unit. Did you get the point?
Yes,
So
sir.
this is all about mechanical advantage. Switch off your mic, please. So this is all about mechanical advantage. Let me tell once again. Mechanical advantage is the ratio of load to the effort. Okay? When load that is divided by effort, then you get mechanical advantage. So mathematically, mechanical advantage equals to load divided by effort. That is L upon E. L stands for load and E stands for effort. So this is all about mechanical advantage. All right. Did you get the point, students? Are you clear? Okay, let me go to the other page. This side, are you clear? Griffith, your video is not on. Why so? User Thapa. Are you clear about that one? That's very good. Okay, now let me share the screen once again. Okay, focus on the screen, please. All right. Now there is, see there. Now we have some conditions there. Okay, so if MA is greater than 1, okay, you can see there. If mechanical advantage is greater than 1, what happens when mechanical advantage is more than 1? So you can see there, when mechanical advantage is more than 1, load lifted by the machine is greater than the effort applied. Okay, in this case, when the mechanical advantage of the lever is more than 1, in that case, load is lifted by the machine is greater than effort applied. That means if you want to lift the load of 10 Newton, then you'll have to apply less than 10 Newton force when EMA is more than 1. Did you get the point? When mechanical advantage is more than 1, okay, in that case, load lifted by the machine is always less than effort applied. If you want to carry, let's say if you want to carry 1000 Newton load, then in that case you'll have to apply less than 1000 Newton force. Okay, no need to apply 1000 Newton force. You got the point? If the lever or if the machine has mechanical advantage more than 1, if the lever has mechanical advantage more than 1, and by applying less effort, by applying less force, you can carry heavy load or you can lift heavy load. Okay, so in that case mechanical advantage is more than 1. Now go to condition number 2. If mechanical advantage is less than 1, what happens when mechanical advantage that is less than 1? In that case, load lifted by the machine is less than effort applied. Okay, when MA is less than 1, load lifted by the machine is less than effort applied. Let's say if MA is less than 1, suppose you want to carry, suppose by the help of machine, you want to carry 10 Newton load, but the machine has MA less than 1. In that case, you'll have to apply more than 10 Newton force. So you get the point? If you have to carry 10 Newton load, then you'll have to apply more than 10 Newton force because the machine is not capable since it has MA less than 1. Okay, the machine is not capable. Okay, it is maybe the machine that is affected by frictional force. All right, the machine is not being able to work properly. In that case, the MA is less than 1, and when the MA is less than 1, the machine is not efficient. The machine does not carry load. Okay, the machine carries load, but the load is less than the effort applied. Right, so in that case, there is no use of using machine. Now go to condition number 3. So if mechanical advantage that is equal to 1, okay, if ma equals to 1 or equal to exactly 1, in that case load lifted by the machine is equal to effort applied on the machine. Okay, that means if you have to lift 10 newton load, then you'll have to apply 10 newton force. If you have to lift 100 newton load by using machine, in that case you'll have to apply 100 newton force. That means there is no use of there is no advantage of using machine, okay, having ma equal to 1. And there is also no advantage of using machine having ma less than 1. There is only advantage of using machine whose ma is always more than 1. So these are the conditions, please keep it in mind. What happens when ma is more than 1? What happens when ma is less than 1? What happens when ma is equal to 1? So these are the conditions. I hope you people are clear. Okay. So students, are you clear about that one? Sunishit Acharya, please switch on your mic. Sunishit, do you hear me? Will you please switch on your mic? Okay, Saugat, switch on your mic, please. Students, do you hear me? Saugat, switch on your mic, alright? Saugat, switch on your mic right now. Now tell me, what happens when ma is equal to 1?
If MA is equal to 1, the load lifted by the machine is should be equal to the load.
Load, okay, that means the load lifted by the machine is equal to the load, sorry, is equal to the effort applied on the machine, okay. All right, load is equal to effort, okay. Now Susant, please switch on your mic right now. Susant Ranabat,
Yes, sir.
what happens when ma is equal to, sorry, what happens when ma is greater than 1?
Sir, I can't see the slide properly.
You cannot see the slide properly. Okay, let me share the slide once again, okay. Did you get the
Yes,
point?
sir.
Okay, I shall share once
Yes,
again.
sir.
Please go through the slide thoroughly, all right? Now see there. Now can you see, Susant? Can you see the slide right now? Susant, do you see the slide right
Yes,
now?
sir.
Okay, now see the condition there. So basically we have three conditions, all right? One and
Yes.
okay.
Yes, sir.
Now let me explain,
Yes,
right?
sir.
Okay, now let me explain. Please switch off your mic right now. So as I told you earlier, there are three conditions. When ma is greater than 1, that is condition number 1. See there, this is the sign of, this is greater than sign. When ma is greater than 1, load lifted by the machine is greater than effort applied. Suppose, let me give you one example. Suppose you want to lift 20 Newton load, and there is one machine, and you don't want to lift the load directly by your hand. You want to use a machine. Let's say the simple machine is a crowbar, okay, and by the help of crowbar you want to lift 20 Newton load. In that case, if the crowbar has ma more than 1, then in that case you don't have to apply 20 Newton force. You can apply only, you can apply less than 20 Newton force. That means when, okay, when ma is more than 1, load lifted or load carried by the machine is greater than effort applied by the machine, okay. Load is more and effort is less. That is condition number 1. And in condition number 2, when ma is less than 1, when mechanical advantage that is less than 1, I hope you are listening me. When ma is less than 1, when ma is less than 1, load lifted by the machine is less than effort. Load is more, effort is, sorry, load is less, effort is more. See the condition there. Load lifted by the machine is less than effort. And go to condition number 3. When ma equals to 1, load lifted by the machine is equal to effort uh, effort applied on the machine. That means when you have to carry 10 Newton load, okay, by using machine which ma is equal to 1, in that case, okay, load equals to 10 Newton and effort equals to 10 Newton. So these are the conditions. So students, are you clear about the situation? Okay, Kabya Adhikari, please switch on your mic right now.
Yes, sir.
Now tell me, what happens when ma is more than 1?
If MA is greater than 1, then the load lifted by the machine is greater than the effort applied.
For example, can you give example? Let's say you have to carry 20 Newton load, okay? That means how much force you need to apply in that case. Let's say you have to carry 20 Newton load, all right? And you are using one simple machine which ma is greater than 1. Now tell me, in that case, how much force has to be applied? More than 20 Newton? Less than 20
Less
Newton?
than
Or let me finish, okay?
less.
Let me finish first. Let's say you have to carry 20 Newton load and you are using a lever or you are using a machine whose MA is greater than 1. So in that case, how much force you'll have to apply? Less than 20 Newton, more than 20 Newton, or equal to 20 Newton?
Less than 20 Newton.
Okay, that's brilliant. Good. Okay, Sushant Rana Bhatt, do you hear me now?
Yes, sir.
Let's say you are using one simple machine whose mechanical advantage equals to 1.
Yes, sir.
Now you are using 20 Newton force to carry the load.
Yes, sir.
Now tell me,
Yes,
how
sir.
much force has to be applied? Less than 20 Newton, more than 20 Newton, or equal to 20 Newton in that case?
Equal to 20 Newton, sir.
Very good. Fantastic. Well done. Okay. Now you people are clear, okay? Now let me go further. Alright, now let me share the screen once again. I was not Bosnet. Will you please switch on the mic once? Now tell me. Let's say you are using a simple machine whose mechanical advantage is less than 1. Yes, and you are given 10 and you are lifting the load of 10 Newton. Load equals to 10 Newton. Now tell me, how much force has to be applied or how much effort has to be applied? Less than 10 Newton, more than 10 Newton, or equal to 10 Newton in that case? You think, you thought, what thought? You should be clear in that case, right?
10 meters, sir.
Not 10 meter, 10 Newton. Why less than 10 Newton?
Yes.
Sir,
Why less than 10 Newton? Why not more than 10 Newton?
sir, because it is in less than 20 Newton, sir.
Because MA is less than 1, you should say, okay? When MA is less than 1, then you'll have to apply more force. When MA is more than 1, you'll have to apply less force. When MA is equal to 1, then you'll have to apply equal load, equal force. All right? These are the conditions, okay? All right, now, okay, let me share screen once again, okay? Niharika Khadka, are you clear? Will you please raise your hand if you're clear? Niharika Khadka, if you're clear, then please raise your hand, okay? That's great. Now, let me share screen once again, okay? Okay, so this is all about mechanical advantage. Now, let us go to the next slide, okay?
Using simple machine.
Okay, all right, let me go to the next slide. So now we are going to learn next term, that is velocity ratio, that is noted by VR. See, can you see the slide properly? I hope you people can see the slide properly. Velocity ratio, that is noted by VR, and you can see the definition there. So the basically velocity ratio means that the ratio, it is also one kind of ratio. It is the ratio of distance moved by effort, distance moved by effort to the distance moved by load. Okay, see the definition there. Velocity ratio is the ratio of distance moved by effort to the distance moved by load. All right, when the effort distance is divided by load distance, okay, see when effort distance is divided by load distance, then we get PR, that is equal to velocity ratio. So see there once again, velocity ratio, as I told you earlier, velocity ratio is the ratio of distance moved by effort. See that, okay, the length covered by the effort, okay, the length covered by the effort when divided by the length covered by the load. That comes, then in that case we can calculate velocity ratio. So you can see there, velocity ratio of a machine is not affected by frictional force. You know one thing, just keep it in mind, okay? VR is not affected by frictional force, whereas mechanical advantage is affected by frictional force. Okay, that's why VR is always greater than MA. Did you get the point? Mechanical advantage is affected, it is affected by the frictional force. Okay, frictional force affects the mechanical advantage but not velocity ratio, which is why velocity ratio is more than mechanical advantage. All right, since the mechanical advantage is affected by frictional force but not velocity ratio, which is why VR is more, mechanical advantage is less. VR is more, MA is less. So mathematically VR can be calculated by the formula effort distance moved by effort by upon distance moved by load. You can see on the slide there. In shortcut, you can say distance moved by effort, that is known as effort distance ED, and distance moved by load, that is known as LD. So this is all about VR. Okay. So students, are you clear about that one? Listen once again. Here, okay. Effort arm when divided by load arm. Okay, distance moved by effort, that is known as effort arm. When effort arm that is divided by load arm, then we get VR. All right. Let's say effort arm is 10 meter. Let us suppose effort arm is 10 meter and load arm is 5 meter. 10 meter When divided by 5 meter, meter and meter cancel out, 10 by 5, that is 2. So VR equals to 2. Let me give you one example, okay? Let me share the screen once again. See there, okay? One example. Example number 2. Question. Calculate
Slide is not clear.
velocity ratio of a machine whose 10 meter, let's say effort arm is 10 meter and load arm 5 meter. So this is the question. So the question says calculate VR. Okay, VR equals to what? Let's say equals to VR has to be calculated. VR equals to what? So this is the question. You can see the question clearly there. Alright, students, see that. Calculate velocity ratio. Okay, third one you can write VR. Bracket should be clear. So VR equals to what? And you are given that here, okay, whose effort arm is also known as effort distance. Okay, effort arm equals to given that 10 meters. So right there, effort arm and effort distance both are same. Okay, effort arm equals to, that is 10 meter. Similarly, load arm. What is load arm there? Load arm equals to 5 meter. And we know what is the formula to calculate VR. VR equals to, we know the formula. What is the formula to calculate VR? VR equals to effort arm divided by, effort arm is also known as effort distance. Okay, don't be in confusion. Effort arm and effort distance are same from a load arm. So that is the condition, alright? That's the formula. Now equal to, now put the value. What is the value of effort arm there? That is 10 meter. 10 meter, like the meter as well, upon 5 meter. Okay. Equal to should be at right place. You should not miss equal to, right? Right there, equal to. Now see there, meter cut cancel out, isn't it? Meter can be cancel out. 10, see there, meter cut out. That is 10 upon 5, 2. Therefore, VR equals to 2. Okay? And you know one thing, it also does not have any unit. Unlike mechanical advantage, okay, like mechanical advantage, it does not have any unit. So this is all about VR. Okay, students, are you clear about that one? So that is all about VR. Okay.